In this video, I'm going to walk you through 3 different types of problems when it comes to classifying matter due to composition. This video is aimed at showing you the process and exactly how to approach these types of questions. Today we're going to work through 15 questions dealing with the following topics: identifying a substance as a pure substance or mixture, identifying a pure substance as an element or compound, finally identifying a mixture as a homogeneous or heterogeneous mixture. With all that being said, let's jump on in. Our first 5 questions are going to deal with identifying substances described as pure substances or mixtures. Remember, a pure substance is only made up of one type of component, while mixtures can contain 2 or more different types of components. If you're wanting some extra practice, you can always pause this video in between questions to attempt to classify these objects on your own. So here we go. Substance 1, pepperoni pizza. Looking at a pizza, you can see several different components, such as the cheese, the crust, and the pepperonis. Because there are multiple components that make up this pizza, I would consider a pizza a mixture as opposed to a pure substance. Substance 2, a glass of pure water. Because this is pure water and there is nothing else in the glass but water, that means there is only one type of substance that makes this up, meaning this is a pure substance. Substance 3, laundry detergent. Laundry detergent is made up of many different types of chemicals and compounds. Though it may look uniform in appearance, it has loads of different chemicals that make it up. This means that laundry detergent is a mixture. Substance 4, salt water from the ocean. Ocean water is made up of water molecules, salt molecules, and many other different types of compounds and minerals. This means salt water from the ocean is a mixture. Substance 5, sodium chloride, also known as table salt. Though salt consists of 2 different types of elements, sodium and chlorine, they are bound together to form a single compound. Because this compound is universal throughout all table salt, the sodium chloride is considered a pure substance. Now the next 5 substances that we are going to be dealing with look at pure substances, and we are going to be classifying these pure substances as either elements or compounds. Remember, an element is a substance that cannot be broken down to anything simpler, while a compound is a substance that contains 2 or more different elements at a fixed ratio. So, substance 6. Oxygen is a diatomic molecule, meaning that it cannot exist by itself as a single molecule. It must pair with another oxygen molecule to form O2. O2 is an example of what type of pure substance? Now this one may be a little bit tricky. You may originally think because there are 2 oxygen atoms bound to each other, this would be a compound, but that would be wrong. Compounds are composed of 2 or more different types of elements. O2 consists of 2 of the same type of element, oxygen. This means O2 is an element. Substance 7, H2O, also known as water. Water molecules contain 2 hydrogen molecules to 1 oxygen molecule. That means there are 2 different types of elements that make this up, making it a compound. Substance 8, carbon. Carbon is a pure substance that cannot be broken down to anything simpler. Because of that, it is also an element. Substance 9, sodium chloride. Sodium chloride is also known as table salt, as you learned earlier. Because this is made up of 2 different elements, sodium and chlorine, it is considered a compound. Substance 10, glucose, C6H12O6. Glucose is a complex molecule containing 3 different types of elements. That easily makes this a compound. Now for our last 5 questions. These questions are going to be dealing with mixtures and identifying whether a mixture is homogeneous or heterogeneous. Remember from our lecture, homogeneous mixtures appear to be uniform throughout. You can't tell that it's made up of different components. While heterogeneous mixtures can visibly vary from sample to sample. In other words, you see the different types of components in each sample. So, substance 11, pepperoni pizza. Because we see the different components that make up this pizza, the pepperonis, the cheese, the crust, and all those components can vary from bite to bite, a pepperoni pizza is considered a heterogeneous mixture. Substance 12, a bowl of salsa. Again, we can see the different components that make up this salsa, such as the tomatoes, the cilantro, the jalapenos, and the onions. Because of this, salsa is considered a heterogeneous mixture. Substance 13, a chlorinated swimming pool. Though we know swimming pools have loads of different chemicals in them, we rarely see anything that looks different than water within the pool. This makes chlorinated swimming pools a homogeneous mixture. Substance 14, a bowl of Lucky Charms cereal. In this cereal, we see milk along with the different pieces of cereal, such as the marshmallows and the cardboardy cereal stuff. Because we see all these different components and they can vary from sample to sample, this makes it a heterogeneous mixture. And finally, number 15, sweet tea. Though sweet tea contains sugar molecules and tea molecules, you cannot visibly tell the difference between the sweet tea and unsweet tea, which contains no sugar. Because sweet tea is uniform in appearance, it's going to be considered a homogeneous mixture. Well, that's all I have for y'all today on classifying matter due to composition. I hope this helps you out and shows you how to approach these types of problems. Remember, you can always rewatch these videos to help you understand different parts that you may be a little confused on now. If you feel comfortable with these types of problems, then you are more than welcome to go ahead and view the next lecture in our series or just view our unit playlist. As always, keep up the good work in your classroom and see you next time.